Hey everybody, welcome back to Mr. Aparicio's geometry course. Today we're going over section 1.4 on the perimeter and area of polygons on the coordinate plane. Perimeter is the first measurement we're going to discuss today, and it's simple enough. It's just adding up all the sides on our polygon, getting the sum of the lengths of all of those sides. So as we look at our quadrilateral here on the left, that's a four-sided shape, a quadrilateral. We would use a capital P to represent the perimeter, and we would just add all these values up. In this case, we have two A's and two B's, and so the perimeter would just be A plus B plus B, just adding all of those side lengths together. All right, so this would just be an example where we don't have exact lengths. If we look at the triangle on the right, we do have all three sides given there. So in that case, we would just do 10 plus 7 plus 12 to get our perimeter of 29 units for that triangle. The challenge in this lesson is that we're going to have to find perimeters on the coordinate plane. And there's going to be two ways that we're going to do that. One way is going to be to just count, and that's going to be for any sides that are horizontal or vertical, where we can just count with our fingers. For any sides that are not horizontal or vertical, we're going to use the distance formula that we learned in section 1.3. So we're going to find the perimeter of triangle ABC here, and we're going to have sides that we can count and a side that we cannot count. For the sides that we can, remember we're looking for horizontal or vertical. So vertical, side AB here, we can count with our fingers. Horizontal, BC, we can count with our fingers. So we can absolutely count AB and BC. Sorry for my handwriting. So for AB, again, I can just count with my fingers. That's 1, 2, 3, 4, 5 units long for side AB. For BC, 1, 2 units long. The side that we cannot count with our fingers, that diagonal side, AC. So remember, for these sides that are diagonal, we can find out how long they are with the distance formula using point A and point C. So that's the work that's going to be required for this problem. In order to find that out, I'm going to write down the locations of these points. Point A was at 1, 6. Point C was at 3, 1. Hopefully you remember that we are doing this so that we can label these points and plug them into the distance formula. So one point is x1, y1. The other point is x2, y2. Those are going into my distance formula. The square root of x2, which is positive 3, minus x1, which is 1 squared, plus y2 minus y1 squared. So y2 is 1 minus y1, which is 6 squared. And we're doing our parentheses, so 3 minus 1 is 2. 1 minus 6 is negative 5. Next we have our exponents. 2 squared is positive 4, negative 5 squared is positive 25, and 4 plus 25 will give me the square root of 29. So I counted side AB, 5 units long. Side BC I counted as 2 units long. Side AC I needed to use the distance formula. It gives me the square root of 29. I can now find the perimeter of this triangle by adding all those values together. So the 5 from side AB plus the 2 from side BC plus the square root of 29 from side AC. 5 plus 2 is 7. For the square root of 29, we can put that in our calculator. Since these are not square roots, we're going to have to get the decimal rounded here in order to combine these. So square root of 29 is about 5.4. Fine with rounding to the nearest tenth here. And then we will add those together to get our perimeter of 12.4 units for this triangle. So perimeter is pretty simple. Area is a much more complex measurement, mainly because different shapes have different formulas in order to find their area, but also because on the coordinate plane, shapes can be sitting in very funky ways and make calculating with area formulas a challenge. All right, so let's first understand what area is. Area is just the 2D space that a polygon or a shape occupies. And on a coordinate plane, that would literally be the amount of squares on your graph that fit inside of the shape would be its area. There would be certain shapes that we need to find the area of right now. Other shapes we're going to learn the area formulas for them later in geometry. For now, we really need to know the parallelogram and the triangle. And we're first going to look at the parallelogram. So what a parallelogram is a quadrilateral that's a four-sided shape with opposite sides that are parallel to each other. And the main types of parallelograms you might already be familiar with are the rectangle, the rhombus, and the square. Here's just an example of what a parallelogram looks like. Just notice that the arrows show you that sides are parallel. So these are opposite sides that have the same amount of arrows, makes them parallel. These are opposite sides with the same amount of arrows. Those are parallel. That's what a parallelogram looks like. For every parallelogram, so that's all rectangles, all rhombuses, all squares, they all have the same area formula, which is, I'm just gonna write capital A for area, base times height. So if we can identify the base and the height of any parallelogram, we can calculate its area. Now, I find the first thing that we need to find is the height. Height is always going to be perpendicular. It's going to make a right angle with something. If you think about your height, if you are 6 feet tall, you would measure from the top of your head straight down to the ground. You wouldn't measure diagonally to some place on the ground that's far away from you, right? So heights are always going to make a right angle with one side of our shape. We can identify that here as this dashed line in here. So it's important to note, the height of this parallelogram is 6 centimeters. It's not 8 centimeters. So we have a height of 6. Our base would then be the side that that height is touching, which is our 12 centimeters here, not our 8 centimeters. So our base becomes 12, and we can now calculate area with our formula of base times height. So our base of 12 times our height of 6 would give us an area of 72 centimeters squared. And area is a two-dimensional measurement. That's why we would put units squared for this. 72 centimeters squared for this parallelogram. For the triangle, which is just a three-sided polygon, our area formula is a little different. Area is base times height divided by 2 for a triangle. You'll often see this as 1/2 base times height. I like writing 1/2 as dividing by 2. It's the same thing. Right, this formula is actually derived from the formula for the area of a parallelogram. So if you think about a parallelogram, if I put a diagonal in it, it creates triangles. So the area of one of these triangles would be half of the parallelogram, which would be found by dividing by 2. So base times height divided by 2 is how we find the area of a triangle. Remember, we identify heights first by finding the thing that's making a right angle with one side of our shape. That would be the 10 here. So 13, 11, 12, none of those are heights. 10 would be the height of this triangle. Our base would then be the side that that height is touching, which is not always on the bottom, right? Bases are not always on the, let me give you an example of that really quick. Heights can go like this, which would make this side over here the base of the triangle. So in this case, it does happen to be the bottom side. This is our height. That right angle is touching the side where the 12 is. So we have a base of 12, and we can calculate our area from here. So remember, that's base times height divided by 2. 12 times 10 is 120. 120 divided by 2 will give us an area of 60. Don't forget units squared for area for our triangle here. Right triangles are very common throughout geometry, and they're unique because of that 90-degree right angle that's inside of them. And it's important that we understand how to identify bases and heights for these, because we're going to see them again throughout geometry. So the base and height of our right triangle are always going to be the legs. Hopefully you recall from a previous math class, the longest side of the right triangle is called the hypotenuse. That's the side that does not touch the right angle. The other sides, the ones that do intersect at that right angle, are called the legs. And because those are perpendicular to each other, either can be the base and the other one would be the height. So you can say 3 is the base and 4 is the height, or 4 is the base and 3 is the height. It does not matter which one we choose. So I could say base of 3, height of 4, and those can be plugged into our area formula for this triangle. So base of 3 times the height of 4 divided by 2. 3 times 4 is 12. 12 divided by 2. Give me an area of 6 units squared for this triangle. Now the coordinate plane is where area can get really tricky, though sometimes we can be lucky and have an example or a figure that's graphed in a way that we can count the things that are needed for its area formula. So in this example, we have a parallelogram on our graph, and we can actually count the base and height of this with our fingers without having to use the distance formula or some other kind of method. All right, for example, I can look at this side down here as a base, and I can count the distance between. That's 1, 2, 3, 4, 5, 6, 7, 8. So that gives me a base of 8. And then a height, remember, would be a perpendicular distance. And the way I can know that something is perpendicular on a graph is that it is vertical when compared to something that's horizontal. So that would just be going straight up and down. So a segment like this one right here could represent the height of this parallelogram. Again, not that diagonal piece on the side. So that's 1, 2, 3, 4 units long for my height. And then I can just use those in the formula for the area of a parallelogram. So base of 8 times the height of 4 would give me an area of 32 units squared. Remember what I said earlier, area is literally now, when we're looking at this, the number of squares that fit inside of that shape. So if we include all those little portions, there would be exactly 32 squares inside of this parallelogram. Perhaps the biggest challenge in this lesson is how we find area when a shape is graphed in a way where we cannot count the base and the height of the figure. So this triangle is an example of that. I have no sides that I can count. There's nothing horizontal or vertical. In a scenario like this, in any other scenario, no matter what the shape is, I like to use what's called the box method. All right, to use the box method, we need to draw a rectangle that's as tall as our shape is and as wide as our shape is. And one important thing to note as we draw this triangle, to be as tall and as wide means these points that are furthest to the left or furthest to the right or furthest up or furthest down need to be on this rectangle that we draw around our shape. So to be as tall and as wide as this triangle, I'm going to draw this in red so that you can see hopefully, we would need to draw this. That would be the top of the rectangle and the bottom of the rectangle. So that's as wide. It goes from the leftmost point to the rightmost point, and it goes from topmost to bottommost, so it's as tall. And then we would connect those endpoints over here to give us this rectangle. This is our box. All right, and the first thing that we're gonna do here to find, again, we did the area of that triangle in the middle. First thing we're gonna do is actually find the area of the box that we just drew. All right, so this box is a rectangle. We would find the area of it by doing base times height. And I'm gonna stay organized over here to the side as I go through this. So this is a rectangle. And I'm just doing base times height. So I'm counting what I need. My base is 1, 2, 3, 4, 5, 6, 7 units long. And just note this, base of 7, we'll do our height is 1, 2, 3, 4, 5, 6, 7, 8 units long. Got a height of 8. I'm plugging those into my area formula. Base of 7 times the height of 8 gives me an area of 56 units squared. So I drew my box, my rectangle, found the area of that rectangle. The next thing I'm gonna do is find the area of the surrounding triangles. So watch what I highlight here in green. Notice inside my box, but outside my original triangle is a right triangle. And that triangle is one where I can count the base and the height of it. You notice all the other triangles, I can count the base and the height of those, something I couldn't do with my original triangle. I'm now going to find the area of all of those surrounding triangles. Hopefully you can see here, there's 1, 2, 3 of these triangles. I'm gonna organize, and I'm gonna find the area of all of those. If I know how to spell triangles. So I'm gonna say organized here, I'm just gonna say triangle 1, and here's my work for that. So area of a triangle is base times height divided by 2. Remember, for right triangles, would be a right angle here in this triangle, the legs would be my base and my height. So that would be this side and this side. So I'm gonna count right here, it's easy, 1, 2. This side I'm counting down to the C where it hits the rectangle. So that's 1, 2, 3, 4, 5, 6 units. So I have a base of 2, height of 6. Base times height divided by 2. 2 times 6 is 12, 12 divided by 2 gives me 6 units squared for the area of that triangle. Now I'm gonna do the same thing down here for triangle 2. Again, I'm gonna stay organized as I go through this. Again, my right angle would be here in this right triangle. That means these would be my legs. That can be my base and my height. This is 1, 2. This bottom side is 1, 2, 3, 4, 5, 6, 7. So 2 and 7 for my base and my height. Here, base times height. 2 times 7 is 14. 14 divided by 2 is 7 units squared. We're almost there. We're going to put this all together in a second. So here's our last triangle. That's inside of our box, but outside of the shape we need the area of. Again, I can count my right angle here. My legs are 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. So 5 and 8 for my base and height of triangle 3. 5 times 8 is 40. 40 divided by 2 gives me 20 units squared for that triangle. And what we do now is one last calculation to find the area of our original figure, which remember was just that triangle right there. What we're going to do is take the area of our rectangle, that 56 units squared, that's our whole box, and we're just going to take away those triangles that are inside the box but outside of the shape that we need the area of. So taking away in math means we're subtracting. So I'm going to do that 56 minus the areas of triangles 1, 2, and 3. Right? So my final area thing that I'm doing is I'm doing the box or the rectangle minus the triangles. So for this specific example, that would be 56 from my rectangle minus the 6 from triangle 1 minus the 7 from triangle 2 minus the 20 from triangle 3. 56 minus 6 minus 7 minus 20 will give us an area of 23 units squared for that triangle in there. So that's definitely a lot more time consuming than one where we can count a base and a height, but this is a level that we need to get to with our area on the coordinate plane. Remember, if you have any questions or concerns for any video lessons, make sure you're jotting them down in your packet. Be ready to ask me those questions in class. Thanks for watching, guys. See you in the next one. Bye.